I know that like Vandla and Atto, you're all using ESS chips and plus ARM CPUs together. So will you have anything like full ARM CPU product, like ARM CPU for digital and then go for analog conversion?
Not exactly. You have to have, basically, you have to have. Okay, most current approaches, these are more or less delta sigma converters. Of course, there are RTR DACs, but I think this crazy thing that people are using this. Basically, it makes no sense at all. That's kind of like reinventing the wheel or something, or using the horse carriages again. These all days they were that these DACs played a major role, but now we have better solutions. And if you do the delta sigma design properly, it gives you much better results. So if we decide, because we partially do already parts we already do parts of the delta sigma converter in ARM chip, as you said, and what we need, in fact, if we decide, we need on the other side of ARM, we need a modulator, delta sigma modulator, and we discussed this. We know how to do it, but we are not really sure, about the effects. Of course, the marketing effect would be big. We would put in our website, wow, we have FPGA plus, and our own modulator, but finally it can be. We would have to increase price a lot, because that's lots of engineering, and I don't see, right now I don't see real need for this, because the ESS chips are kinda they are exceptionally good, but they have exceptional problems as well. and we know how to deal with this. So that's why our designs are better than others, and and that's why they sound differently. And I have really tell you that that ESS we've been using ESS for 14 years or something like this, and I have tell you that since the day one we had big problems with ESS, because something's always not working properly, but at the same time crucial things are very, very good, and for us the crucial thing is the modulator. So if we switch to our own design, we would leave most of the design, plus we would add our own modulator. That's all. So basically, it's kind of it's a matter of decision, and the discussions, if it makes sense for us to do it. Okay, so basically, it's like you look at this, with the lens, and you think, can we do it better? Maybe yes, maybe not. Of course, from the marketing point of view, we have FPGA plus modulator. Oh, we have modulator based on FPGA. Wonderful, we are the best. But but it's not true.
Understandable.
It can be better, but it can be worse.
Yeah, I understand. Because there are a lot of good products that is cooperated with ESS or AKM chips.
Yeah, that's true. That's true.
Because the product design is always look a whole design, not just part of the chips.
Yeah. That's true, and that's how in our design it is done. Because we the modulator part in ESS. Okay, there are two issues here. Two issues. One issue is the chip itself. Okay, and in the chip you can say that there are filters plus this digital part plus the modulator, which is partially digital as well. But let's call it this way: digital parts with digital filters and the modulator. The modulator is good, and then you have these filters, and they could be much improved. That's what we did. So basically, we removed the filters inside the chip, and we used our own ones, and it gives you already the the benefits. But then there is not that clear thing out of the chip, because in our industry most of the companies do it very small, so and they don't have proper resources to do design. So basically they need to do the new design, so they take the data sheet, they read this, okay, let's do it this way, and there's always an application scheme, okay, and the application scheme says use this chip and the other, and some op-amps, some capacitors, some resistors, so they all use the same application scheme, okay? And we do it differently, because we did designs with ESS chips before in MyTech times. We knew what were the weaknesses. So let's say right now we're doing Vandla, we use same chip as we use in Manhattan, but we knew that that the big limitation of this chip, which is itself is very good, was the current output. So that's why we did the new IV converter, and it was, and I have to tell that the solution we made is unique. Nobody in the market does anything like this, and the funny part is this is much simpler, but much smarter. So if you do it this way, you achieve much better results than with original application scheme. But I shouldn't tell this because everybody will be copying this.
Can modern DAC design call a high-speed circuit design?
Yes or no? What you want? Whatever you like.
Yeah, because there's something.
Okay.
I read from the paper. It's all like impedance match. Impedance control everything.
Yeah. Listen.
Multi-layers.
Okay, I will tell you this way. A modern DAC consists of many parts, right? Yeah. There's analog section, which is not high speed at all. That's analog. Okay. We use high speed ICs for the high speed op-amps, but I wouldn't call this design high speed, because it's kind of not the clue here, not the issue. Then you have the DAC chip, all other things. I wouldn't call it high speed as well, okay? But then the parts like microprocessor, USB, or Ethernet, it's obviously high speed, because for example in USB there's 480 kilobits, yeah. So you need so these lines are balanced. So basically you have to draw these lines very very carefully, and taking into account that the impedance has to match. The same is with Ethernet. Then when you use the fast chip to put everything inside, you need to somehow implement sometimes the memory or DRAM or flash, and this is all high speed. So basically the answer for your question is yes and no. It depends upon the part, but of course, as you say, if you took this example of Ethernet here, I can tell you that Ethernet is high speed.
So, except for high speed, the impedance control and matching is very important.
Yeah. So you need to take precautions to do your design properly. Without this, you are doomed.
Because I know when you're doing this complex system design, it has to be multi-layer PCB. So everything has to be.
Not only. I mean, this is one of the things. But for example, when you do the USB. Because that's everybody knows USB, so this is a good example. And there are two data lines, D plus and D minus, and they should match the impedance. But then you should calculate. You go to the website of the board manufacturer, and you have to take all the parameters from there. What is the width of the board, then the width of the copper, then there's this the electric. I forgot the English term for this. The electric constant, and then you have to calculate the proper width of the tracks, the separation between them, and all these things all together to match the impedance. So this is kind of complex thing. Modern softwares let you to cut packages. They help you to draw these things properly. When you just add the parameters, set up the parameters, and then you do this. So it's kind of, if you don't do this, there would be reflections. It wouldn't work. It's not about. Sometimes it could reflect in quality, but very often your design wouldn't work at all. So that's about it's like square wheels in the car. They won't work. It's like the same.
Okay, I understand. So what are the challenges during designing and manufacturing Vandla and Arzo?
Everything.
I can see that.
No, it's like it's I mean, building a company, designing and manufacturing electronics is not an easy task. Because and because we could do this because we are in this market for plus 20 years. Okay, I believe the most important part here is creating a good team. If you have a good team, you can create a properly working design company. And it's always not about one person, because in our films and in our website we always say that I am not the only one person working in my company. There's in our industry there's a popular belief that there's this one genius person, there's this mastermind, this founder, CEO, the most important person. He did all the design by himself. But that's all stupid. Because in good company, sometimes you can do one design and you live with this. So, but in a bigger company which delivers good products, it's all too complicated. You cannot do everything by yourself. So you have to be surrounded by good people. I was doing design by myself, everything. But but for many years I don't do this now. I limited my activities mostly to the role of the CEO and the mentor. So basically my guys are coming to me, they have ideas, and I help them I show them the strong points and weak points of their thinking. So finally, but they do everything by themselves. So two most important guys in my company are Pavel and Max. You saw them on the films. So they are the designers, not me. So basically we are in this regard we are a special company because we show the people who do this. Yeah.
That's very cool.
Yeah,
basically no one's doing this.
Yeah, but we are pretty straightforward. So we just say the truth. So. And this is your question was. It's very complex. The answer for this is very complex. I believe one thing is what is difficult here. One thing is having the team, good team who can do this, and the other is understanding the issue of the time. Because in many companies they are like let's do this. That's simple, and they forget that they need 2 years to finish this. Yeah, so they understanding that the time issue, that you need to spend your time to finish the design. So with Erzo and Vandla, we have good team, so they could build this, and we understand as well the issue of time. So basically we did first Erzo and then Vandla, because we could use in building Erzo, we were already working for Vandla, and when we built Vandla, we could use the effects of Vandla to Erzo. So basically everything is much faster and efficient.